So after studying the four elementary transformations that can be applied on any of our trig functions, I would like to add a note, a special note, in a couple of special cases, but happen quite commonly out there. So let's start out with a function f of x again, being either a sine of x or a cosine of x. So the special note I'm adding here is applicable to any of these functions right here, and in general can be extended to any of the later other trig functions we're going to be later learning. But so we already learned that as an elementary transformation, anytime any one of our trig functions, instead of taking the usual x, it's taking an expression ax, for here generally a could be positive, a could be negative. And so back in my explanation, I tend to call that a plus or minus a for a strictly be positive, like that. But so basically a coefficient multiplied with x in place of the usual x variable. So we already learned that this changes the period of our trig function f of x. And also we learned that when our function, the input of our function is being substituted by an x, either x plus a, or let me use x plus b or x minus b here, then doing any of this is going to change, or it changes the start point. Let's change the start and end of the base unit. So that's what we learned through the elementary transformations. However, keep in mind the elementary transformation we've learned is limited to when the change on the start and the end happened. It strictly requires that the x here is coefficient 1 in front of the x. Or on the other case, when it changes the period, the elementary rule, the elementary transformation we learn is when it's simply one coefficient. It could be positive, it could be negative, but no extra term added on. The challenge comes when our function is taking a linear expression inside of it. And now being a linear expression inside of this input of our function, so a could be positive and negative, and b itself could be positive and negative. So the challenge I'm trying to point out is that it's not exactly f of ax. If it's simply f of ax, then it should be easy to recognize this change the period. If it's simply x plus or minus b, then it's easy to recognize that it changes the start and the end of the base unit. But now it has sort of like both, and that's where the challenge comes. So to overcome this challenge right here and to make it clear, and I can tell you it has both. An expression like this, a complete linear expression like this, has both property. It will change the period, and it will change the start and end of our base unit. So how do we recognize it clearly? So the trick here is to put our linear expression inside of our function into a factor form, where we're going to completely factor out this coefficient a. It could be positive, it could be negative. So make sure you watch the sign carefully, but factor out the coefficient a. Then consequently, what remains inside of that parentheses is going to be an x with coefficient 1 and plus, but b now is going to become b over a. So it will change out the adding term a little bit, but now putting your inside linear expression into a factor form like this, now it's easy to recognize that this A right here could be positive, could be negative, but it's going to be what responsible for the period change. And this B right here is responsible for the start and the end of our base unit, or generally regarded as responsible for some phase shift as that new term being introduced. So now allow me to bring up one example. Let's look at y equals cosine of about minus 2x plus with a pi over 3. And I'm trying to go with some kind of coefficient and adding term that's as crazy as it could, so that once we get it done right here, everybody who views this video is going to have a generality of how to get it done. But so this is that linear, and here's our function being one of the trig function, and similar work can be done here in case you run into a sine of x, a sine function. But here we're looking at a cosine, and the point now is that inside of our cosine we have a linear expression. And so my entire example here is only intended to help recognize what changes the period and what correctly changes the phase shift, the start and the end of a base unit. So the first big step here is to factor out that linear coefficient, that stands right in front of our x term right here. So now I'm going to rewrite my cosine function. And the linear expression inside of my cosine function, as I said earlier in the general description, I am going to factor out my linear coefficient. So factoring out, and I said linear coefficient meaning this time it's a -2 coefficient. So I am going to factor out the -2, and I'm going to have a pair of parentheses. So first term inside of this sub pair of parentheses now is going to be simply just x. And now once we pulled out the negative signs, then of course x here becomes positive term inside of that little parentheses, and the second term now becomes minus. So it's just the elementary algebra that when we factor out a negative common factor, then all the signs that remains, all the signs of the terms remains inside parentheses gonna switch. And so this next term now going to become pi over 6. And so now that here enable me to identify that this 2 with the negative sign is responsible for this is going to cause changes to the period. And this part right here now is making it clear that it's going to changes. That part right there is going to change it. It's going to change the start and the end of a base unit.